In this lecture, we'll talk a little bit about the basic C operators, all the operators that you perform, that you regularly execute in instructions in C. The basic ones anyway, basic arithmetic and logical operations. These operators are very common. You see them in all languages, virtually unchanged in different languages. But we'll go over them. So first, there are constants. You can define constants. There are actually a couple of ways to define constants, but we'll talk about hash define. Hash define is a compiler directive. Again, it's got a hash sign in front of it, so it's a compiler directive. And hash define basically substitutes one string for another. So if you, like here, I say hash define answer 42. So what it does is wherever it sees answer in the file, it substitutes that with 42. So it's just a macro substitution. It says, oh, I see the word answer. I'm going to stick a 42 in instead. Very simple. It happens at compile time, actually before the compile. It's the pre-processing step. It just looks around for every time it sees answer and substitutes the 42 in. You can do this with characters. In that case, it was a number, the number 42. You can do it with character constants too. In this case, if you want it to be a character, you got to put the character in single quotes. So hash define Terminator X. Notice I put the X in single quotes. What it does is, if you put it in single quotes, it knows that it's a character and it interprets it as a character. So it interprets it as an ASCII character, or Unicode, really. So ASCII and Unicode, what they are, I haven't described them, but what they are is every character, visible character or an invisible character, every character you see on your keyboard, for instance, and lots of other characters you can't, they're all mapped to numbers. So X might be 41, and Y might be 42, and so on. They're all mapped to numbers in a table. And if you Google ASCII table, ASCII characters, you'll get a table that lists every character and its ASCII code number, or Unicode is a bigger one. So ASCII is only 8 bits long, really 7 bits. Unicode is 16 bits, so you have a lot more characters. But ASCII and Unicode overlap. So X, lowercase x, has a certain representation, a certain number, and in turn, if you put it in single quotes like that, it will know, oh, this is meant to be a character, so I will represent it with its ASCII value. And it looks it up at the table and stores that. Some characters are not easy to represent, meaning they're invisible characters, like a bell character, which actually in old machines used to make a beep sound when you would click it, control. I can't remember, it's been a while since I used such a machine. If there's a control keystroke, control something, it would make a beep. That you can't see it, right? It's one of those invisible characters. So you can't. So if you wanted to represent that as a character, you can do it, but you have to give the ASCII code number, which is not something we're going to necessarily get into. So they're constants, and you can use hash define to define those. Now, C has a set of arithmetic and relational operators, standard stuff. So plus, minus, times, divide, all that. The percent sign is a modulo operator. So modulo is the remainder after division. So for instance, 9 modulo 2 is equal to 1, because if you do 9 divided by 2, you get 4, and the remainder is 1, so 1 is what's returned. Or 9 modulo 3 is 0, because 9 modulo 3, if you say 9 divided by 3, you get 3 perfectly, and there's no remainder, so 0 is the remainder. So modulo is basically the remainder. Plus plus is an increment. So if you want to take a variable like x and increment it, you say x plus plus. If you want to decrement it, you say x minus minus. There are comparator operators, relational operators. So equal, equal. And actually, this is something to be careful of in C and other languages. If you say x equal 1, that's an assignment. That assigns x to be 1. But if you say x equal 1, that is a test. It's a relational operator. It returns true if x is actually equal to 1 and false if it's not. Okay? So you would use x equal 1 if you have an if statement. Like here, take a look at my if statement down there. X is less than 5. So if x is less than 5, do whatever, right? So in that case, you're using a relational operator as a test. So x less than 5 returns true or false. True if x is less than 5 and false if it's not. So equal equal is a relational operator. It's a comparison, which returns true if the two things are equal, false if they're not. And they're used in if statements commonly and conditionals and so forth. And so those are the common relational operators. Arithmetic, all the common relational and arithmetic operators. Also, you have logical operators. So logical operators meaning and or not. So Boolean logic. So for instance, ampersand, ampersand, that's an and bar, bar, that's an or, and exclamation, that's a not. So what happens is these operators treat the arguments as 1-bit binary values. So So take and, right? Ampersand, ampersand. The arguments to that operator are on the left and the right. So you might say 1 and 2. 1 ampersand, ampersand 2. Let's say we did that. So it has two arguments, 1 and 2. These two arguments, it treats them as 1-bit binary values. So even though 1 and 2 could be integers and have many bits, it says, look, I'm going to say you are either true or false. 1-bit binary. And the way it does that is it says, look, if it's 0, whatever the number, whatever the value is, if it's a 0, then that's a false. And if it's anything but 0, then it's a true. So if I said 1 and 2, it would say 1 is true and 2 is true, and then true and true is true, so it would return true. Okay? Because 1 and 2 are both non-zero, so they're both considered to be true. So for instance, this statement, if A is equal to 1 and not B. So first thing is, if you look at that and, it has two arguments. The left side is A equal 1. So that's true if A is equal to 1 and false otherwise. Then on the right side, the not B is the argument. So not B is going to be true if B is false. So if B is equal to a 0, then not B will be true. Okay? And if both of those things are true, if A is equal to 1 and B is equal to 0, then the if statement will evaluate to true and it will execute whatever it's supposed to execute. So that's how logical operators work. They take the arguments and treat them as either true or false, just like a 1-bit Boolean value. Thank you.